Hello, welcome friends. In this video, we will see how the elevation command is used. So to determine the cutting and filling boundary, which through which we can guide on the site from where to provide the excavation, cutting and filling. Where to start from the excavation, cutting and filling. So for this reason, we will first create a surface. We will create a surface with OGL. This is the output which I received from my site, and it is just in the point format. So just by clicking on the point, I can see that it is a block reference with some elevation 90.079. So I can create a surface out of it. So just I will add the data just by surface OGL, by adding definition, and the objects are on the block format, so drawing objects, just select block, description nothing matters. So I will select all the points which have been provided. So here I can see that my elevation to these display is on, so I can see in blue shaded a display images on it. So I will let it off. So the surface has been created, boundaries has been placed. I will provide the boundary to the surface. So this is the plot boundary, which is actually on the site is a retaining wall, compound wall, which is confining the area, and these are the OGL levels. So we will now create an required formation surface, considering it is a 95 RL, and for which we need a drawing object. So we will select this polyline, which has a defined elevation 95. You can see that it has an elevation 95, it's a polyline. So we'll add a polyline through definition and break line. So as it is in polyline, we will add through a break line. We will give a description as 95 RL. Okay, the surface has been created. Let us see, move the surface in the object viewer. Okay, you can see here that OGL and the formation surface, which is 95 RL, has been created successfully. So from here we want to see from where the cutting and where the filling required to level the surface as at 95 RL. So first of all, I will provide the boundaries to both of the surface. You can do it prior or now, it is okay. So this is the surface. So we want to find the ridge line, or the line where cutting and filling required for the 95 RL. So we will create another surface with name volume surface 95, and type we will select tin volume surface. This is to be noted, the volume should be tin volume surface, and the base we will give it as an OGL, comparing surface we will get as a 95 RL, and we will just click OK. Now the surface has been created. Now we will select on the surface, we will right click and edit surface style, edit surface property. So in this property we know the information which the name of the surface, definition and analysis. In this analysis we will select elevation, name of the range by two ranges. We will analyze the surface. So here we can see that the minimum elevation and maximum elevation of the surface is been color schemed in blue and yellow, black. So we will consider maximum elevation to be 0 and the minimum elevation from the cutting to be up to minus to 0, and we will color those surface. And we will just add this elevation range. Now it is nothing happening, so we will select the surface, right click, property styles, and here we will select the elevation bulb. So now here we can see that the brown color is the filling area and the green color is the cutting area. How can we determine? Then we will add a label, spot elevation 0. This is the volume surface elevation, which is 0. With plus 1.1 shows that it need to fill 1.1 meters for 95 RL. And we will select an OGL surface and we will add an spot elevation and we will select on the ridge line. So here we can see that it is 95. So from here we can easily instruct on site that from where you have to start filling and from where you have to start cutting. This is the easy method to determine the cutting and the filling area on site. Then we select our volume surface and we will add a label for elevation, which is dynamic, showing its area for the specific elevation which we have selected for cutting and filling. So this is it. Thank you.